right, we've got sections 5.3 and 5.4, which I'm kind of combining together, but it's all going to be related to trig functions. So you already know the big 6 trig functions: sine, cosine, tangent, cosecant, secant, cotangent. Not only do you know what they are, but you know that if you have an acute angle, just an angle that's less than 90 degrees, so maybe something like that guy, call him theta, then you can form a right triangle. There's my right angle. And you can use SOHCAHTOA to figure out all your trig functions that you might need, right? So if you know the opposite side and you know the adjacent side, you can always use Pythagorean theorem to get the hypotenuse. And once you have all the sides, you can get all of your trig functions. Okay, so that works really well. But what happens when you don't have an acute angle, or you just have a number, not really an angle at all, okay? So that's what we're exploring today. So what about other angles or just numbers? So suppose I still want to do a trig function on that. You know, maybe figuring out the tangent of some number or some weird angle. How could I go about it when I don't really have this nice right triangle where I can use SOHCAHTOA? It has to be a right triangle because I need a hypotenuse, right? That's what the H stands for, okay? So we're going to recall some previous language and terms. Standard position is one of them. That's standard position of an angle. Okay, so when we talk about standard position, we talk about having an x-axis. So I'm going to draw in an x-axis. That's my origin right there. My circle's a little off. It's kind of hard to draw them on a nice vertical surface, right? So just pretend it's a circle, perfectly formed. And we always form our angle by starting at the x-axis and traveling counterclockwise if it's positive, clockwise if it's negative. So let's say I do that. Let's say I have my angle and I just go counterclockwise. And now that's my theta, okay? And maybe a problem is asking me to find the sine of theta, okay? Well, I don't see a right triangle immediately, so using opposite of hypotenuse seems not applicable, okay? We're gonna make it be applicable in just a moment, okay? We're gonna form a right triangle, okay? So after you measure the angle, again, you don't need a protractor. You're probably going to be doing a little bit of estimation, right? This is just some pretend angle. We're going to do it generically once, and then we'll apply this method to specific problems for practice. Then we form a right triangle. Okay, now there's different options here, but we have to be very particular about which one right triangle we're using. Form a right triangle by connecting the terminal side, there's another term we've used before, to the x-axis. Okay, so terminal side, that's where the angle terminates. That's the end, okay? So I need to go from this terminal side down to the x-axis, okay? So I'm going to do that right here. And if I go straight down, I do form a right angle, okay? Not only do I have a right angle, but I should start to see a right triangle in there. So I've got this piece, and this perpendicular right here. That's my right triangle. That's the triangle I'm going to use with SOHCAHTOA to figure out the trig value of non-acute angles, okay? We're still not quite getting there. I need a little bit more. All right, so in this right triangle, I have numerous angles. I've got the right angle, got the angle way up here, and I've got the angle right by the origin, right? Here's my origin. That angle in the origin, he is the one I want to focus on. That's an angle that I'm going to call theta subscript r, okay? So after I form this right triangle, I'm going to determine theta r, which is the reference angle. And this reference angle will always be acute, will always be less than 90 degrees because he's part of a right triangle. It can't be more than 90 because then otherwise I don't have a triangle, okay? So once I have this figure, then I can start using SOHCAHTOA on it, okay? So if I think about this as the origin, this is 0, 0. If I move myself left, right, left and right, those are x distances. They're along the x-axis. If I move myself up or down, those are y distances, right? They're vertical amounts. Again, we're doing this generically once, and then we'll do it specifically with actual values for a few additional problems as practice. I am going to enforce, unless it's otherwise stated, that the hypotenuse here, this distance is 1. So if you've seen this figure before, or you maybe knew where I was headed, we call this a unit circle, okay? Unit, because that's what the number 1 is in mathematics, it is 1 unit. And it is a circle with a radius 1. So this is a unit circle, okay? From here, I can answer just about any trig function you throw at me. If it asks for the sine of theta, okay? Yes, I drew theta, but I use the reference angle and its right triangle. Sine, okay, sine is the so part, opposite over hypotenuse. So opposite theta, r, the reference angle that I'm using right now, is y. The hypotenuse is 1. So if I write y over 1, that actually simplifies. Dividing by 1 does not change a number's value, right? 10 divided by 1, 10 cookies, divide them to one friend, you still have 10, okay? So division by 1 doesn't change anything. The cosine of theta, okay, I see where theta is, but we use the reference angle to determine its cosine. Cosine, ca. Adjacent over hypotenuse, okay? So there's two things adjacent to our theta r. There's the x and the 1. 1 is the hypotenuse, so x is the adjacent side. So I have adjacent over hypotenuse, which again simplifies. Division by 1 does not change a number's value to just x. And these are the important properties we're going to use, okay? If it asks me for other trig functions, I can always form them using some of our equations. Tangent is sine over cosine. We developed that in a previous lesson. So tangent is y value over x value. I could also just go back to the triangle and use TOA, opposite over adjacent, and I'd get the same results, okay? So these are the steps we're going to do. Measure the angle, form a right triangle, determine the reference angle, and then use sine as the y value, cosine as the x value. If it asks for other trig functions, cosecant, I would do the reciprocal of sine. Secant, the reciprocal, so flip the cosine, and cotangent, the reciprocal, so flip the tangent, okay? All right, so we are going to leave this circle up here. And we'll use it. Let me put the origin back in there so I kind of know where my center mark is. All right, don't have to be perfect, but maybe about right there. Okay, so let's look at what this will be when we have a very specific angle. And again, I'm operating in radians. We are done with degrees except for a few maybe application problems. We need to be comfortable in radians, okay? So if I am asking for 5 pi over 6, okay? I could go back and translate this to degrees and then measure it with degrees. I'm not going to do that. If you need to do that on your own right now, that is okay. I'm going to present an alternative. If you don't like the alternative, you're going to translate this to degrees, which we did in the angles video, and then you're going to figure out, measure it for where it is in degrees. What I'm presenting is a shortcut where we don't have to go to degrees and then back to radians, okay? So on our unit circle, this is exactly 0 radians. Okay, right? I don't measure anything. I haven't moved counterclockwise. I haven't moved clockwise. I'm at 0 radians. It's also 0 degrees, okay? If I go straight across, okay, so if I have this angle, we know that's 180 degrees, and we know an equivalency between degrees and radians. 180 degrees is pi radians. So I have very little room right now, but I'm going to write pi right there, okay? That's pi radians. Now, think about just measurements on a ruler, okay? halfway in between 0 and 1 pi, right? Picture this coefficient, it has a 1 in front of it, 1 pi. I'm going to be at half a pi. So halfway in between, let's make a nice straighter line. Halfway in between is half pi, right? Just like you would have a ½ inch or something like that, okay? I'm going to use this information to try to figure out where 5 pi over 6 is, okay? That's 0, that's pi, okay? What I'm going to do is look at the denominator here, 6. I need to divide this into 6 equal pieces, okay? When I say it, I just mean the top half of the circle, because I'm going from 0 radians to 1 pi radians. Okay, so if I divide the top half into 6 equal pieces, 1 piece, 2 piece, 3 is right here, halfway in between. That should make sense if I was going for 6. 4 pieces, 5 pieces. Okay, let me label what I mean. This is 1 pi over 6. This is 1/6 of the way to 1 pi. This is 2/6 of the way, so it's 2 pi over 6. This one is pi over 2, but if I think about it in terms of 6, it's this unreduced fraction of 3 pi over 6. Those are equivalent. This is good, right? I'm getting the thing that I think I should get. 4 pi over 6 is the next one. 5 pi over 6 is right here. And if I kept going, this would be 6 pi over 6. Think about how that fraction would cancel. These are equivalent. So I divide the top half into 6 equal parts, and I want the 5th one, okay? So this is where I'm at. This is my angle right here. These other marks were just helping me get there, okay? Once I'm there, all right, so I've measured the angle. It will go quicker the more we practice, and I'll go through it a little bit quicker after we've done this one. I'm going to form a right triangle by connecting the terminal side, that's where the arrow ends, down to the x-axis. Okay, so I'm going to outline this right triangle to the origin, the hypotenuse, and this vertical height right there, okay? So, form the right triangle. Determine the reference angle. The reference angle is always formed not by the original theta, there's my original theta, but by the acute angle living inside this triangle, okay? So, I'll do that in a different color. This is theta r. So I'm going to determine theta r here, the reference angle, okay? Because of all the work I've already done, I won't have to recreate anything. I'm not memorizing formulas. I'm looking at, okay, to go from 5 pi over 6 to 6 pi over 6. How far did we go? Well, to go from 5 to 6 is 1. But I'm not just going 1, I'm going 1 pi over 6. Okay? What I'm really doing is looking at the difference between these two fractions. 6 pi over 6 and 5 pi over 6 is a difference of pi over 6 units. Okay? Pi over 6 units is a 30-degree angle. We had that on the previous video where we needed those equivalencies for the 30, 60, 90, 45, 45, 90 triangle. So what I have already done is created a 30, 60, 90 triangle, okay? So I've labeled it in degrees on one side, 30, 60, 90, and in radians on the other side, okay? And I've used the same measurements, the 1/2, the √3/2, same thing over here. This is just the reverse side. There's the right angle. They're the same measurements we had in the previous video that talked about these special triangles. The hypotenuse, distance 1, just like our unit circle hypotenuse. So if I look at this, there is my right triangle right here. 30, 60, 90, okay? So from this information, I can figure out anything about this angle that I want. I can figure out its sine. What is the sine of 5 pi over 6? Let me actually write that in there. Okay, well, sine of 5 pi over 6 is the y amount of my triangle here. Y amount is the up-down. I can also use SOHCAHTOA if that's helpful, but y amounts are vertical. That's labeled as this distance of a half. You might have trouble seeing that from that far away, but the up-down amount is a half. I'm just using previous knowledge. I need to know this triangle to get that answer right. If I don't know this triangle, I'm sunk. I really can't solve future problems. I could also figure out the cosine of 5 pi over 6. All right, so I don't have to recreate anything. It's the same angle, same reference angle, same triangle. But if I'm asking for cosine, I'm now asking for the x amount. The x amount is the left-right distance. How far do we move along the x-axis, okay? So you'll see, again, sorry, it's kind of sideways. That's just the way I oriented it. Root 3 over 2. That is coming from the two special triangles we've already developed. If you don't know this triangle, you can't get the right answer. You have to know this. Flip back in your notes, repeat it, create something like this, whatever it takes. You gotta know this guy, okay? This answer's not right though, because the problem is we're living on an XY coordinate axis. I went left. That's where the negative x values are, right? If I go to the right, that's positive x. If I go to the left, that's negative x. So there's my cosine. Once I have sine and cosine, I could obviously get tangent or any of the rest, okay? I'm going to do another one, all right? If something still has not clicked, proceed through the next one. Try to focus in on what part you got lost at. Was it measuring? Was it forming? Was it determining? Was it figuring out the special triangle? And see if you can adapt for the next problem, okay? So for this next problem, let's call it alpha. All right, we'll give it a different Greek letter name. Let's do alpha equals negative 3 pi over 4. Okay, so I want to keep this circle up here because I kind of measured it ahead of time to make it look how I wanted it to. But what I don't need is all the information about the previous problem. Okay, so I don't need these 6 marks at all. Okay, I just want the origin and my 0, and let me rewrite that pi in there, okay, because that was important. For negative 3 pi over 4, all right, it's a negative angle, so I need to go clockwise this time, okay? And instead of dividing a half of the circle into 6 parts, if I go from 0 to pi, I want to divide it into 4 parts, and I'm looking for the third part, okay? So divide the bottom half into 4 parts. Well, if I just have a straight vertical line, I've divided it into 2 parts, 1 part, 2 parts. 4 parts then would be dividing into like quarter sections. So this is 1 pi over 4, negative, because I'm going counterclockwise, 2 pi over 4, negative, because I'm going clockwise, and 3 pi over 4, again negative. That means this value here, not only is it pi, but it is 4 pi over 4, negative because I went clockwise. Okay, so my angle alpha is the third entry. Okay, negative 3 pi over 4. Didn't have to convert to degrees, didn't have to resort to memorization, just divided half of the circle into fourths, and I took the third part. So that's measuring the angle. Now I want to form a right triangle by connecting the terminal side to the x-axis. Okay, so do that the following way. Actually, I'm going to have to erase this because otherwise I run out of room. All right, it's connected to the x-axis. It forms a right angle. I've got my right triangle. Now I have, in this right triangle, an acute angle right by the origin. Instead of calling it theta r, I'm going to call it alpha r. I'm going to determine what alpha r is. Okay, what is the reference angle for this figure? All right, so I got pi units here, 3 pi over 4 here, okay? What is the difference between these two? Okay, remember what pi was equivalent to? 4 pi over 4. So to go from 3 pi over 4 to 4 pi over 4, we're traveling a distance that is 1 pi over 4. You can also just look at the picture, right? If each one of these segments was a pi over 4, I have one of them. That's it, okay? Now from here, if I know I'm at pi over 4, this is a 45-degree angle. If you're questioning how we're getting this, you gotta go back. You gotta look at the previous video. You gotta look at the chart we formed. You gotta look at the special triangles to know that pi over 4 is 45 degrees like that, okay? So just like our 30, 60, 90 triangle, I created this one, 45, 45, 90, or in radians, pi over 4, pi over 4. These values, the lengths of the sides, were developed in a previous video. If you don't have this one, that means you probably didn't have the other one, and you gotta recreate this. Write it down numerous times. draw a little triangle like this. Whatever it takes, you gotta know this guy. Otherwise, you can't solve any questions regarding this angle. So, all right, form your triangle. Oh, there he is. Okay. So if the problem asks me, let's do something more interesting. Let's say it asks me for the tangent of alpha. Tangent is sine over cosine, which we've developed is the equation y over x. Okay, so in this situation, it's asking me, what is my y value, what is my x value? Y is the up-down amount. How much should we go up or down on the triangle? That's a root 2 over 2, right? It's upside down here because of I had to flip it to make it fit. But root 2 over 2 is one of the side lengths of the 45, 45, 90 triangle, okay? Now, but notice, it's below the x-axis. So it's a negative root 2 over 2. The x value, that's how much you move left or right, okay? So my x value is also root 2 over 2. And it's also negative because it's moved to the left of the origin. Any number divided by itself is 1, and a negative over a negative is a positive. So my final answer is that the tangent of, let me not write alpha here, but the tangent of negative 3 pi over 4 is positive 1 unit. Now I could have also used TOA from SOHCAHTOA and looked at opposite over adjacent and gotten that same answer as well. But I already had this equation up here, so I figured might as well just use it, okay? All right, that should get you started on how to use the unit circle, but you have to make sure that you can document all of these things. If you have unit circle memorized, that's great, but I need to be able to evaluate more than just your memorization skills. So on a test upcoming, you'll have to show me evidence of how you've measured an angle, how you formed the right triangle properly, how you've determined the reference angle. And then it's really just up to these guys. If you know your two triangles, you can figure out sine is the y value, cosine is the x value, and any trig function question I ask, you can be successful on.